Alright, so our next type of equation to take a look at is where things are starting to get a little rough. Not as bad as they're going to get next, but this type here goes back to exponential equations. We started with exponential equations, and then we moved into logarithmic, and now we're moving back to exponential equations. So, the type of exponential equation we're going to look at is ones where you have exponential on only one side of the equation and not on the other. Exponential, remember, means the variable appears up in the exponent. So, your first step of a problem like this is, and this actually kind of is in the background of just about every other type as well, is to isolate the exponential part here. So what that means is we're going to have to take the 65 and move it over to the other side. That's not particularly difficult. It might seem kind of obvious, but make sure you do it. So 7.2 to the x equals 65. And then we're going to do, actually, in a sense, the reverse of what we did in the previous video when we were dealing with logarithmic equations. With those ones, when you had a logarithm on one side, you would move the base to the other side. Well, we're going to move the base back to the other side. So in this case, when we say move the base to the other side, that means the 7.2. That's the part that's the base here. And remember, when you move the base from one side to the other, it's still going to be the base of something. In this case, it's going to be the base of a logarithm. If it's the base of an exponential on one side, it'll be the base of a logarithm on the other side. And then that's an ugly looking logarithm, but hey, we just learned in the previous section of the book, 12.5, we just learned how to work out logarithms on a calculator. So you grab your calculator, you work out using the change of base formula. You're going to have to do log of 65 in the top divided by log of 7.2 in the bottom, just in case you've forgotten how the change of base formula works. And you're going to get 2.114597, and who knows how many decimal places. Sometimes they ask for like 2 or 3 or 4 decimal places. I'm not really sure. And this part you're going to really love, this is actually one of the nicest things about this, is there's no little asterisk. Notice the asterisk that we have with the logarithmic ones? We don't have these ones here. So you can check your answer, but it's optional. Oops, checking, the G, I know how to spell. Checking is optional. Here's how you would do the checking. You would take the 2.114, etc., and you would plug it into the original equation. Remember, when you're checking, always plug into the original equation. Never use an equation where you've already done some kind of work. And you would do all of that checking on the calculator, of course. You would go 7.2 exponent 2.1145977737 minus 65. And the calculator will not give you precisely 0 because really there's more decimals than you can ever see on a calculator. So when you're typing it back in, these are not all the decimals. You've cut it off at the end there and it's not a perfect match. 7.2 to all of this is not quite going to be enough to cancel with 65 to produce 0. So what it'll do is it'll give you an answer that's really, really close to 0. On my calculator, at least, what I'm seeing right now is 2.5035 e negative 8. And what that means is 2.5035 times 10 to the negative 8. It's scientific notation. And what that means is 0.000000 0.025035. Let me make sure I got the right number there. 1, 2, 3, 4, 5, 6, 7. Yes, I do. And is that equal to 0? Well, not exactly equal to 0, but since this has been rounded off and we're using a decimal, a close approximation for the answer, that counts as a check. That verifies that, yeah, that's got to be right. If it wasn't right, if you'd made some mistake somewhere, it wouldn't have been anywhere near that close at all. So let me go through the steps again. When you have an exponential on only one side of the equation, isolate it, move the base to the other side, and then work out whatever you're looking at that point. You don't have to check if you're confident you've done the steps right, but if you want to check, checking is done on a calculator. The other thing is, sometimes these logarithms, you can do them by hand. If you can do them by hand, please do them by hand, if nothing else, so that you practice and know how to do that type of